Hello everyone. Today we discuss the matrix theory. Okay, so already in class 12, already you have learned what is the matrix, then determinant, what is the addition, multiplication, inverse of matrix, that type of thing already you know. Here actually we learn little bit different. That is, there is some new type of operation on matrix. Okay, so first we start with the linear equation solve. That thing you have done in your class 9 or 10. Okay, for example, suppose you have a system x plus y equal to 1. Okay, and second equation 3x plus 2y equal to 2. So this type of equation, how to solve? So basically what you can do, if you try to eliminate this y, so you can think this is your equation 1, this is your equation 2. So first multiply your equation 1 into 2, so you have 2x plus 2y equal to 2, and you have 3x plus 2y equal to 2, right? So after that, if you do the subtraction, right, so then basically this is your suppose new equation 3. So if you do 3 minus 2, so what you have basically, then you have basically x equal to 0 once, and the first equation you have as it is, basically 2x plus 2y equal to 2, and you have x equal to 0. Now if you substitute this your x equal to 0 here, so from there you will get your solution x equal to 0 and y is equal to 1, right? So this type of thing already you have done in your 9-10 level. Okay, now what we'll do here, we will write this type of system or we solve this type of system using matrix. In class 12 level you have seen this type of system you can write as your suppose 1 1 3 2, and then you have xy, right? If you see the matrix multiplication, basically you have the same thing. What I am doing actually, I am writing the coefficient of x and y on the first row, and similarly the coefficient of second equation of coefficient of xy in the second equation in the second row. In this way I am writing this system. Okay, so after that you can think here I am multiplying my the first row with 2. Okay, so basically in your new system r1 dash, you are doing 2 into r1, right? So then you have this thing 2 2 3 2 xy and 2 2. After that you can think 3 minus 2, so basically what you are doing, r2 dash, basically you are doing r2 minus r1, right? So whatever you are doing, you have to do the same thing on the right also. Okay, so if you do in this way, you see 1 0 xy equal to 2 and 0. So whenever we are doing here r1 dash is equal to 2 r1, here basically we are not doing any operation on second row, so that's why that is fixed. Okay, whenever we are doing here, so then we are not doing any operation on your first row, so that's why these elements are same. Okay, so in this way you are getting the same thing. Okay, so Now if you consider your again one more operation, if you do for example so basically 2 into r1 dash is equal to r1 minus 2r2. if you do, so what you have basically 0 to 1 0 x y equal to 2 0. So this imply actually 2y equal to 2 and x is equal to 0. So from there you are getting the same thing, right? So basically what you have some matrix. After that you are doing some operation. Okay, so this type of operation is actually called the elementary operation. Okay, so here actually you have seen basically two type of elementary operation, that we are multiplying a row with some constant number. Okay, and we can do some addition or subtraction, this type of thing. Okay, so in general whenever we will start the elementary operation, you will see mainly there are three operations. Okay, so here I am listing what are the type of operation. Okay, so elementary operation. Okay, so there are three type of elementary operation. Okay, so if you are applying on the row, then it is called elementary row operation. If you are applying on the column, so then it is elementary column operation. Okay, so let A be n cross n matrix, then any one of the following three operation on the rows or column of A is called elementary row or column operation. So what are the type of operation? First one, interchanging any two rows or column. You can write this column in bracket, columns of A. This is one type. Okay, what are these types? Suppose you have 1 2 3 4. Okay, suppose you want to change this operation. For example, if you write r1, you want to change with r2. So basically then your first row will be your second and second will be your first. So this is the type. Okay, different book there are different notation. This type of notation sometimes written is this, or sometimes it is written like r12 also. Okay, so there are different type. So this is your first row operation. Okay, second is your similar for column also, it may happen. Okay, then your column will exchange. Second is your multiplying any row or column of A by a non-zero scalar. Okay, so how this type of thing looks like. For example, suppose you have 1 2 3 4, you are doing operation. Suppose r1 dash will be your 2r1, so that means your 1 2 will be multiplied with 2. Okay, so it will be 2 4 3 4 like that. Remember, this is your non-zero, you cannot multiply with 0. Okay, this type of operation. The third one is adding any scalar multiple of row or column of A to another row or column. Okay, so how this type looks like. For example, suppose you have 1 2 3 4 and you are doing operation r2 dash. Suppose r2 dash means whatever you have dash, that means that row will be changed. Okay, suppose you are doing r2 dash will be r2 minus 2r1. Suppose you need this operation. Okay, so what you have, r1 will be no change. Okay, 1 2. In the second row, basically whatever your r2 value, then minus 2r1. So basically here you have 3 minus 2, so that means 1. Okay, here you have 4 minus 2 into 2, that means 0. So this type of thing. Okay, similar for column also it is possible. I am giving a just column example. Suppose you have 1 2 3 4 5 6. Suppose you have this thing and you are doing C1 dash will be C1 plus C2. So how it looks like, so column 1 it will be changed by column 1 plus column 2. Okay, so it is like 3 and 1 plus 2 is 3, 4 plus 5 is 9, 2 3 5 6 like that. Okay, so these are the three type of elementary matrices. Now you may think why, so how you choose that what operation you have to apply. Okay, so basically you will see later. For example, whenever we are solving this, what our target, to find the value of x and y, right? So basically you want some diagonal type of matrix if you get so that what's happened, if you have this type of matrix, you see it is very easy to find the value of x and y, right, instead of this type. Okay, so you have to obtain the diagonal or similar type matrix using your row and column operation. Okay, so these are the type. Okay, so these are the thing. Next we will, suppose I am considering a example. Okay, so most of the cases you will see you try to obtain some identity block matrix. Okay, for example, suppose you have example, suppose I am considering a matrix 1 2 3 1 0 1 1 minus 1 1. Okay, so I am actually following a book. That book is Feedback, Linear Algebra, Stephen H. Feedback, Initial Feedback. So if you have the schema, that abstract and linear algebra, you may follow that book. I don't have that book at my home, so that's why I'm following this. If you are finding any difficulties in their notation, you can send SMS in WhatsApp. Okay, anyway, so what our target from there, I want some matrix like suppose 1 0 0 0 1 0 0 0 1 or 0 0 0 or this type of thing. Okay, that you will see after doing operation. You will see which operation you have to do. So first what you have to do, suppose you have some element, okay, then your target will be the below of that element will be 0. Okay, all the next what you will have, you will target will be you have some element here, then above and below the element should be 0. So that type is actually some echelon form, or a row reduced echelon form that will do later with proper definition. But for the time being, I'm just showing that how this row operation or column operation works. Okay, so you say this is 1, no issue. So what I am doing r2 dash equal to r2 minus r1. Why I am doing? Basically I am trying to make this element 0. Okay, okay, so 1 2 3, then you have 0 minus 2 minus 2. Check if I am wrong. Basically what I am doing, 1 minus 1 0, right? 0 minus 2, so minus 2, 1 minus 3, that means minus 2. Okay, and then you have the 1 minus 1 1, right? This is you have. Now you can obviously, when so many operation you will write, so your calculation will be very lengthy. Instead of that, what you can do, you can do 2 operation in your one line also. What how, for example, if I write r3 dash equal to r3 minus r1, that also you can do. Okay, so then your this will be changed to 0 r3 minus r1, that is your minus 3, then 1 minus 3, that is your minus 2. Okay, you see 2 0 is coming. Okay, next your target is you have to make this element suppose 1. Okay, so how can you can make, you have to use your which operation, basically you have to multiply it with 1 by minus 2, basically the second one, right? Second one if you use, basically r2 dash equal to r1 times 1 by minus 2. If you do, what you have, 1 2 3, only change will be in your r2, sorry, this is your r2. So 0 1 1, right? And then you have 0 minus 3 minus 2. Okay, next what you have to do, you have to use some operation. For example, suppose you have to make this element 0 and this element 0. How you can make, r1 dash equal to r1 minus 2 r2, and if you do r3 dash equal to r3 plus 3 r2, right? In this way, you see there is some pattern. Whenever I am writing r2 dash, the next element is actually r2, then whatever the operation I am writing. Okay, so you observe this operation very carefully. Okay, I am not writing that for example in r3 dash I am not writing that minus 1 by 3 r3 plus r2, this type of thing I am not doing. Okay, whatever the operation you are writing, the next you have to write same. Okay, anyway, if you do this operation, so you see r1 minus 2r2, so r1 minus 2 into this, right? This thing you are doing. So what you have, this is 1, this is 0, and then you have 3 minus 2, that is your 1, and this is as it is. Okay, next thing, 0 minus 3, 0 minus 3 minus 2, right? So basically r3 plus 3r2, so this is 0, no issue. This is also 0, and then you have minus 3 plus 3, that is your 1, right? So this is operation you have. Okay, now what you have next, suppose we want this is 1 as it is, so next operation, suppose we want r1 dash equal to r1 minus r3. So what is our target? This is 1 already. If it is not 1, then we divide that with that number. Okay, and above there are some 1. I am trying to make this thing suppose 0. So what operation you need? r1 minus r3. Okay, and then r2 dash will be r2 minus r3. So if you do this thing operation, so you see 1 0 0 0 1 0 0 0 1. So using some row operation, you are you got the identity matrix. Okay, okay, so in this way you are making this. So the total thing I have done using row. Similar thing you can do using column, but the most popular is for your row one. Okay, now the next thing is what is your elementary matrices. Okay, so whatever the operation you have learned here, if you apply this type of operation on your identity matrix on IN, so that type of matrix is actually called the elementary matrices. Okay, so if you rename this, the first one suppose type 1. Okay, this is your type 1, this is your type 2, this is your type 3 type of operation you have learned, right? So if I write the proper definition of elementary matrix, so basically an n cross n elementary matrix is a matrix obtained by performing an elementary operation on IM. Okay, so basically you have seen earlier there are 3 types, right? For example, if I say type 1 elementary matrix, so how it looks like, what is this type 1? Type 1 is actually interchanging of any 2 row, right? So if you do the same operation in your identity matrix, so how it looks like, for example, if you swipe your first and second row in your identity matrix, if you consider just 3 cross 3 matrix suppose, so it is 0 1 0 1 0 0 0 0 1. So this is also a elementary matrix. If you do in this way 1 0 0 0 0 1 0 1 0, this is the type of 1 elementary matrix. Okay, Next, type 2. Type 2 is like, what is the type 2? Multiplying any row or column by some non-zero scalar. For example, suppose you have one first row, you are multiplying with suppose 2. So 2 0 0 0 1 0 0 0 1. Okay, this type. Okay, there are some another name also. This is what you have swiped, your first and second, right? So this thing is denoted by E12. This is the notation. Okay, if you give some competitive exam, there you may see this type of notation. Okay, so I am also highlighting this thing. Okay, so how this your second one, you can see this is the second and third, so you can write this is E23. Okay, this type. Here what you have done, this type 2 one, you have multiplied with 2 in the first row, so this notation you can write E12. Okay, this type. Okay, so if you have 1 0 0 5 0 5 0 0 0 1, so you can say this thing is your, this notation is your E2 into, suppose this is -5, so -5, like that. Okay, there are your second type, so type 3 elementary operation, type 3 elementary matrix. So what the operation type 3? Adding any scalar and scalar multiple of a row of a to another row or column, right? So suppose you know you have 1 0 0 0 1 0 0 0 1. So suppose you are doing some operation, just I am thinking like, suppose you are doing R2 equal to R2 plus 2 R3. So what are you are getting here? So 1 0 0 0 1 0, sorry, R2 will be changed, right? So it will be, I think, 2 0 0 1, this type, right? Check this thing. Yeah, so this type of thing. Okay, so you will write this type of elementary operation is basically where, what are the operation you have done? 2 3, right? Because you are doing R2 plus 2 into R3, so it is E23 into 2, this type of notation. Okay, this is the notation E23. Okay, so you can think in this way also, that whenever you have the 2/3 element is 2 in your identity matrix, so this is the notation, right? In this way also you can think. Okay, I am doing one more. Suppose you have you have I3 and you are doing operation R1 dash is equal to R1 minus 3 R3. So what you will get? 1 0 minus 3 0 1 0 0 0 1, right? Make sure this, that you are getting this. So this thing you can write with E13 with -3, right? So these are the 3 type of elementary operation. You see how this type of operation, one is your E12 E23, but there are no element, right? So this is your type 1. Whenever you have single thing, you EJ and then you have number, that is type 2, and whenever you have EIJ and with some number, so that is your this type. Okay, so these are the 3 types of elementary matrices. So your homework is in I3 I3 write in I4. In I4 write the following elementary matrices. Suppose you have E23, E14 minus 5, next E2 into minus 7. Okay, these three matrix you write and then send me in the WhatsApp. Okay, just this is I4, that is you are doing the same thing in your 4x4 matrices. Okay, so this is your elementary matrices. Okay, so basically why you are getting the same thing, later you will learn. If you multiply this elementary matrix on the on your any matrix, you will get the same operation. Okay, for example, you know the matrix multiplication well. Okay, for example, suppose you have 1 2 3 4 5 6 7 8 9. Okay, suppose you are doing the operation R2 dash equal to R2 minus 4R1. Okay, so what you will get, 1 2 3 4 5 6, so this is your 0, 5 minus 8, so minus 3, 6 minus 12, so that is your 6 minus 12, what you will get, 6 minus 6, then 7 8 9, like that, right? Now instead of doing this, just think R2 minus 4R1 is corresponding to which elementary matrices. You can think this is your E21 minus 4, right? I think it should be clear from your previous discussion. This is your online link, you just go backward and again listen. In this way it will be, I think, more good for you also. Okay, so I think this is clear that if you do this R2 minus 4R1 in your identity matrix, you will get E21 minus 4. How this matrix looks like, basically this is your, you can think that 1 0 0, basically 2 1 element will be minus 4, right? 1 0 0 0 1. So you know this matrix. Okay, now you just check if you operate this E21 minus 4 on this matrix 1 2 3 4 5 6 7 8 9. Okay, what is this? Just matrix multiplication. You know this is your 1 0 0 minus 4 1 0 0 0 1 into, you have 1 2 3 4 5 6 7 8 9. You just check if you do this multiplication, you are getting this matrix or not. Make sure this thing. Okay, and if any problem, let me know in WhatsApp. Okay, and if somebody have some previous year question in this, that classical algebra and matrix theory, send me in WhatsApp, because I don't have access on the previous year's question. If you have the previous year question from seniors, so send me that also, so that I have an idea that where we have to focus more. Okay, so today I have completed just first 2 things. Okay, the next class we will complete the remaining. Okay, bye. Let me know by tonight. Okay, tomorrow we have the same class.